X. And I'm going to have 1 up here known as our GY. Okay, up to now it's okay, right? So we are going to take, moment at point G. Why I decide to take moment at point G? Because then I can find Cx, to find Cx. If I were to take moment at point C, I have 2 unknowns. Okay, basically that is the fact. Okay, so I'm going to take moment at point G. So summation about moment in the z direction at point G is equal to 0. Okay, so 400 is going to go anti-clockwise 400 multiplied by 12, 12, 12, 12, 24, 36. Okay. Then plus by 1600 multiplied by distance of 12. And then the 400 is going to go clockwise. Okay. And then we have Cx. Cx is going to go anti-clockwise, so I put plus Cx. The distance is 16. The whole thing will be equal to 0. Is this clear? This is okay, right? So
Yes,
16 Cx is equal to 400 times by 36 plus by 160 times by 12 minus by 400 times by 12 is equal to, 400 times by 36 plus 160 times by 12 minus 400 times by 12. So it's minus 28800. Okay, 28800. So let me do it. 400 times by 36 is equal to 140 plus by 1600 times by 12 minus by 400 times by 12. So it's positive or big. So Cx is equal to 28800 divided by 16 is equal to 1800. Okay, so my guess direction is wrong. The correct one is going this way. Okay, so Cx is equal to 1800 pounds and going towards the left hand side. Can you all check the answer for me? Am I right or wrong? Okay. Same value. And Cx is 1800. Okay. Okay. So the next one, I'm going to do dimension of forces in the x direction is equal to 0. So we know now our Cx is going towards the left is minus 1800. And I guess my Gx in the wrong direction is okay. So now Gx is equal to minus 1800, okay, pounds. So the correct direction is Gx is equal to 1800 and it should be in the opposite direction. So the correct way of doing it is you just cancel and just put in the correct direction, okay, on the free body diagram for this case, okay. Then we have positive is going up, summation about forces is equal to 0. So now we have minus 400 minus 1600 minus 400 plus by gy is equal to 0. So gy is equal to minus, so it's 400 plus by 400 plus by 1600 is equal to 2400 pounds and is going upwards. Okay, all these are in pounds. Okay, is it correct? Gy is 2400. It's correct, right? So from here,
shouldn't the arrow be the other way for Gx?
Say it again.
Shouldn't the arrow, like the what's called vector arrow after 1800 pounds, shouldn't it be pointing towards the left because it's negative?
At this stage, when it's negative, means the direction is wrong. Does not mean negative is towards the left.
Okay.
So that's why when this is minus 1800, I assume it to be pointing towards the left is wrong. So I have to flip the direction.
All right, based on your assumption. Okay, thanks.
Okay. Okay. So now we have everything now. Okay. The trick to this problem is the moment. Okay. The problem with this question is the moment. Okay. So if now we focus on the beam. Okay, if we now focus on the beam. Okay. So this is point A, point D, point E, point F to point B. Okay. We know over here it has 400. We know over here we have 1600. We know over here we have 400. Okay.
Eugene,
Now,
why did we exclude C and point G?
not yet. I did not exclude. I'm not done yet. Hello?
Yes.
Okay. Because Cx over here is going to induce a moment. And this moment at point D will be equal to 1800 multiplied by a certain distance which is equal to 8. So this will be equal to 1800 multiplied by 8, which is equal to 14400. Does this make sense now? Yes or no?
Yes, it does.
Okay. And, right, it's going to induce a horizontal reaction, okay, which will not affect. So this horizontal reaction is 1800, right? It will not affect our shear force diagram. Does that make sense now? Right? It is because this 1800 that you see now is inducing on the what? This is where we have our so-called centroid. Okay. Right? It's on our centroid. So it will not affect our shear force diagram. Can you see that now? Hello?
Yes.
Okay, it makes sense. Okay. So at point F again, we are going to have a moment induced by Gx. Okay. So over here, we are going to induce a moment at point F. And this moment is going to cause a what? It's going to cause a Gx is equal to what? Gx is equal to 1800 multiplied by a distance of, what is our distance? Multiplied by a distance of 8 again. Okay. So this will be 1800 times 8 is equal to 14400 pounds. So 1800 times 8, 14400 pounds. Okay. Now this is caused by the Gx, right? And then we know that it will come in a horizontal. It will have, so Gx is also equal to 1800. But at point F, we have a Gy. And Gy is not inducing a moment, but a force. Does that make sense now?
Yes.
Okay. So are you confused because of this, or we have to go further?
I think that was my confusion.
Right? You can see where the relationship is, right? And you realize that when it's horizontal, it is not affecting the shear force diagram. Am I right? Is then when it's vertical, this one will affect because Gy will affect because Gy is in the what? The shear force direction. Okay. Okay. So in fact, this is a very good question. Okay, it's linking to what I've been always taught to you, right? Because the important aspect is where is the centroid. Okay, like when we have compound loading. Okay. Opara, where's your question now?
From homework 11, question 11.
Sorry, Eugene. Just before we move on, I had a quick question. When we take the distance from D to E, do we multiply x with the moment as well?
Say it again.
When we consider, when we solve for equation from D to E, do we multiply the moment
D to E?
Yeah, do we multiply the moment at C and D with the value of x?
Is that question because we are finding the reaction? Hello?
Yeah, no, my question is that when we solve or when we find the equation for shear force and bending moment from D to E, from the point D to E, do we multiply?
Why B to E?
Because
Okay,
we break it into segments, correct?
Huh?
Because
You cannot do B to E. You can do B to F, F to E, E to D, D to A. You cannot do B to E. You cannot jump
I think
point
he was
F.
saying D to E. I think he was saying D to E, not B to E. It's D to E.
Yeah, like D to E, delta.
Okay,
Yeah.
why not I form the shear force and bending moment equation from A to point E? Okay, watch.
Okay.
So we are going to form A to point D. So A to point D is 0, 0, x to 12 inch. Okay. So over here, we have a force of 400 pounds. Okay. So this is our x, right? So this is V as a function of x, M as a function of x. Okay. So summation about forces. So it's equal to minus 400 pounds minus V as a function of x is equal to 0. V as a function of x, okay, is equal to 400. Minus 400, sorry. Then when we take moment, summation of moment, Z as a function of x is equal to 0. So this will be equal to 400, 400x plus by M as a function of x is equal to 0. M as a function of x is equal to minus 400x. Okay. Now, at point D, where x is equal to 12 inch, okay, now you have to include the what? So now this is still what? 400, right? So now you have to include the moment at point D, which is 14400 pound inch. Okay, so still V as a function of V at point D and M at point D. Okay, so positive is going up, summation of forces is equal to 0. So this is still equal to minus 400 minus V at point D is equal to 0. V at point D is still equal to minus 400 pounds. Okay. The next one, that's where the moment is different. M as a function of Z at point D. Okay, now we are taking moment at point D now. The difference now is this. We have a moment at point D. So this is our point A, and this is our point D. So this will be equal